So in this video, we are going to be talking about cross products, which is basically where if you have a proportion, all you need to do is just multiply both sides by each denominator, and what you end up getting is basically the cross products. So cross products, it just allows you to almost skip a step of saying, hey, I'm going to start by multiplying both sides by b, and this cancels, and then I'm going to be multiplying both sides by d, and then this cancels. It basically allows you to just say, hey, I'm just going to multiply this d to this a and this b to this c. So that is what that cross products is. It's just a quicker way of simplifying if and only if you are looking at proportions. So you have two fractions that are equal to one another, and that is it. So that is the only time you can use these cross products. If you have two proportions that are equal to one another, so you only have two fractions that are equal to one another. So again, you can see that this is just basically what I was saying, just in terms of words, numbers, and algebra. So let's look at a problem using these cross products. So let's look at this first problem. So we have 3 over 9 equals 5 over m. So this is a proportion because we have two fractions that are equal to one another. So what I'm going to do is I'm going to cross multiply, or cross products. I'm going to multiply this m across the equal sign, and I'm going to multiply this 9 across the equal sign. So we get 3 times m equals 5 times 9, and we know what 5 times 9 is. That is 45. So this is now just a normal solving problem. So I just need to go and divide both sides by 3. And I get m equals 15. And it may be that you know what the answer is already because these are proportions of one another. That means that these ratios are equal. So 3 over 9 equals 5 over what? And you may have just said it in your head, oh, that's just 15, because what you did was a proportion. You knew that it was basically 1/3. So the top number or the bottom number is 3 times larger than the bottom one. Sometimes, though, it's not that easy to see. So let's look at this problem. So we have 6 over the quantity y minus 3 equals 2 over 7. So again, the first thing I noticed is that I actually have a binomial in a fraction. So anytime I see a binomial in a fraction, I'm going to put it in parentheses before I even start the problem. So now that I've done that, we can start the problem. So I see that I have proportions set up. I have two fractions that are equal to one another. So I can do cross products or cross multiplication. So I can multiply this quantity of y minus 3 across the equal sign, and I can multiply this 7 across the equal sign. So doing that, I get 6 times 7 equals 2 times the quantity y minus 3. So on the left side, 6 times 7 gives me 42. And on the right side, I'm now at the pass where I need to say, hey, should I distribute that 2, or could I divide it out first? And I see that the left side is an even number, and what I'm multiplying with is 2, so that means I would actually divide out quite nicely, so that's what I'm going to do. I'm going to start by dividing both sides by this 2. So 42 divided by 2 gives me 21. And on the right side, this 2 divided by 2 cancels, leaving me with y minus 3. So at this point, nothing is being multiplied to this parentheses, so I can just get rid of it. And this is just a one-step problem now. Something is being subtracted to what I'm solving for, so I'm going to add that on both sides. So on the right side, the -3 and +3 are going to cancel to 0. And on the left side, 21 plus 3 gives me 24. And that is my final answer. So I have two u tries for you to try out. You have -5/2 equals y over 8, and you have the quantity g plus 3 over 5 equals 7/4. So pause the video and try them out. So on the first one, you would have gotten y equals -20. And on the second one, you would have gotten g equals 23/4.